We're looking at graphing logarithmic functions today. Okay, graphing logarithmic functions today. Before we do that, I want to remind you how are exponential functions and logarithmic functions related? They're inverses. What does it mean to be inverses? The x and y are switched. Okay, so keep that in mind as we're doing some of this. Okay, we're going to start with a basic one first that does not have any shifts. And then once we get the basic shape of it, then we'll do some that have shifts in it. Alright, so I have y equals log base 3 of x. And I want to graph this. Like I said, we usually want to look at the transformations first. Like I said, this one does not have any. So, the next thing we need to do is talk about the asymptote. What type of asymptote did a exponential function have? It had a horizontal, right? Okay, so what type of asymptote is a logarithmic function going to have? It's going to have a vertical. Does it make sense why? Because the horizontal asymptote is y equals 0, correct?
Yes.
And how are exponential functions and logarithmic functions related? And what does it mean to be an inverse? X and y's are switched. So instead of y equals 0, it turns into x equals 0 because the x's and the y's are switched. So I'm going to have a vertical asymptote at x equals 0. And just like on exponential, my horizontal asymptote is always y equals 0 unless I do what? Unless I move up or down. Okay? With logarithmic, it's always going to be x equals 0 unless I do what? Move left or right. Okay, so keep that straight. Alright, now when you pick your points, it's a little bit more difficult to pick your points on a log function than it is an exponential function. Okay, on an exponential function, what is it I'm interested in? What makes the exponent 0? Okay, so I'm kind of doing the reverse of that. So I would normally plug in 0 over here on the left, correct? Because that would make the exponent 0. But if I would normally plug 0 in for x, where's 0 going to go this time?
Y.
It's going to go for y. So I know this is going to be 0. Okay, and what else would I plug in?
2 on each side of that.
I would plug in 2 on each side of that. So I'd plug in 1, and I'd plug in 2, and I'd plug in -1, and I'd plug in -2. Okay? So we need to figure out what x values go with those y values. Alright? And we're kind of just doing this backwards the first time through so you can understand why we're choosing the values we choose. Okay? So, I'm interested in what x value makes this thing equal to 0. So what does x need to be in order for this to be 0? Well,
Would it be 0?
it would be 1. Why does it need to be 1?
Because the 0 power is 1.
Correct. So we're asking ourselves, 3 to the 0 power is what? It would be 1.
Oh.
So that's what's going on there.
Wow.
So what needs to be right here on this one? 1/3 needs to be here. What needs to be on this one? 1/9 needs to be there. What about this one? 3. And this one? 9.
Okay.
There it is. Okay? But we're not going to do it backwards from here on out. We're going to go from the left side. So let's notice what's going on with these numbers that ended up being over here on the left.
Multiples of 3.
Okay, they're kind of multiples of 3. What's another way? If we change them all to a base of 3, 9 turns into what?
3 squared.
3 squared. 3 is 3 to the first. 1 is
3 to 0.
3 to the 0. 1/3 is
3 to the -1.
3 to the -1. And 1/9 is
3 to the -2.
3 to the -2. So that is how you choose what x values you're going to plug in. You're always going to take your base to the -2, your base to the -1, your base to the 0 power, your base to the first, and your base to the second. Yes?
Will that always be the case, or will it change when we change the graphing itself, like moving, say, adding +3?
When we move, these numbers over here are going to change, but what we start with is going to be the same.
Okay.
We're going to start with the same. There's going to be a little bit of adjustment to get what x values actually go in the graph. Okay? So once I have this, x equals 0 is going to be right here. I have 1/9 and -2. 1/9 is too small. I'm not going to worry about graphing that one. 1/3 and -1, I can graph that one. So 1/3 and -1 would be about right there. 1, 0 is there. 3, 1 is there. And 9, 2 puts me there. Okay? So that would be there, and then this would go down that direction. All right, one other thing we're interested in when we're dealing with logs, graphing logs, is we're interested in finding the domain. Somebody remind me, how do we find domain if we're looking at a graph of something? Left to right. So I need to know what's my leftmost number. In this case, what is it? 0. And what's my rightmost number? Infinity. So my domain would be 0 to infinity. All right. So let's try another basic one before we get into the shifts to make sure we've got it. All right, so let's do y equals log base 2 of x. Again, like I said, there's no shifts, and since there's no shifts, that means my vertical asymptote is going to be
0.
and it needs to be x equals 0. Okay. So this time, let's work on the x values first, and then we'll get the y's from that. So what x values do I need to choose? 2 to the -2, which is 1/4. 2 to the -1, which is 1/2. 2 to the 0, which is 1. 2 to the first, which is 2. 2 squared, which is 4. And since I'm dealing with 2, I can actually go one more. What's 2 to the third? 8. Okay, most of them, when you go to the third power, it's going to be something that's off my graph. But if I'm dealing with 2, obviously 2 to the third is still on my graph. All right, so now we plug these in. If I plug in, and let's start down here at the bottom. If I plug in 8, 2 to what power gives me 8? 3, so that means this one is 3. I plug in 4. 2 to what power is 4? 2. Okay, what do you notice is happening here? Right. So once I get 2 of them, I should be able to see the pattern. So the next one's got to be 1. I've got 0. I've got -1, and I've got -2. Okay. Your y values, when you choose the x values correctly, like we do, your y values are always in sequential order. Okay. There's always a pattern over there on the right. So x equals 0. And then I've got, let's go 8, 3. I've got 4, 2. I've got 2, 1. I've got 1, 0. Bless you. I've got 1/2, -1. That's probably enough. And there's the graph of log base 2 of x. Okay, without any shifts, pretty simple. We start doing some shifts, that's when people start having a little bit of trouble. So let's talk about the shifts. Alright, so let's say I just have the general form y equals log base b of x. So what things can I do to the log function to where it be a shift? Natasha. I put a negative in front of the what?
The log.
In front of right here?
Yeah.
Okay, so if I put a negative there, what does that do?
Flip over there.
That's over the x. Okay, so if I put a negative there, that flips me over the x. What else? AJ, what were you going to say?
You add a number
Add a number before the log. So if I had 2 plus log base b of x, what would that 2 do? Right. So if I add or subtract something out in the front, that's going to move me up or down. All right. What if I wanted to go left or right? It'd have to be with the x. So if I wanted to do like x minus 2. So if I do something in here that is left or right. Okay, and there's one more we need to talk about. Yeah, if I put a negative in here, a negative in here flips me over the what? A negative in there flips me over the y. Alright, so that's the shift, so let's do some with some shifts. Okay, so y equals log base 4 of x plus 3. So what's my shift? Left 3. So left 3. What's my vertical asymptote?
0. Or x
X equals negative 3. Remember on the log, the left or right shift is what changes your vertical asymptote. So since I went left 3, that means my new vertical asymptote is at negative 3. Alright, so then we're ready for our t-chart. And if I have something inside with the x, I need to do some work on the side before I put numbers into my t-chart. Okay? So let's talk about what numbers, since my base is 4, let's talk about what x values we need to think about. What did we choose on the last one? What do we always choose? I need the negative 2, so what's 4 to the negative 2? 1/16. Then what do I need? We'll get there. I just want the numbers first. I need 1/4, and then I need 1, and then I need 4, and then 16. Okay? Now this one right here, and this one right here, they're either too small or too big, so I really only care about these in the middle here. Okay? Now, if there is something inside with the x, what you want to do is you want to set these equal to what's inside. And then you want to solve for x. Okay? So on this bottom one, if I solve for x, what does x end up being? It ends up being 1, because if I subtract 3, I get 1. On this one, if I subtract 3, I get negative 2, and on this one, if I subtract 3, I get negative 2 3/4. Okay, now here's why we did that. Let's see what happens when I plug 1 in. 1 plus 3 gives me 4, which is what I wanted, because now 4 to what power gives me 4? 1. So that means that's a 1. I plug negative 2 in here. Negative 2 plus 3 is 1. 4 to what power is 1? 0. Once I have two numbers, then I've got my pattern. So what does the other one have to be? The other one has to be negative 1. So I don't have to waste my time plugging it in. Okay, so now I've got the numbers I need, and I've got my vertical asymptote. So vertical asymptote is negative 3. I got negative 2 3/4 and negative 1, so negative 2 3/4 and negative 1, somewhere in there. I've got negative 2, 0, and I've got 1, 1, which is right there. Okay. So then I should be able to graph it from that. So it's going to go down this direction. It's going to level off that direction. All right, we forgot to do it on the last problem, but what would my domain be on this problem?
Negative 3 to infinity.
Negative 3 to infinity would be my domain, because my leftmost value is my negative 3, and the rightmost would be infinity. What numbers are always going to make up your domain? The vertical asymptote and infinity or negative infinity. That's what will always make up your domain. The vertical asymptote and either infinity or negative infinity always make up your domain. All right. Let's try another one. And I get y equals log base 3 of x plus 7 and then minus 2. Y equals log base 3 of x plus 7 and then minus 2.
So that means it's gonna move left 7 and down 2.
Left 7 and down 2, I agree. So Kendrick, what does that mean my vertical asymptote's going to be?
-7.
Negative 7, excellent. Negative 7. Everybody understand why it's negative 7? Christian?
In any of these graphs, will they a horizontal
No.
asymptote or it's a vertical asymptote because we're switching the x and y?
Correct.
Okay.
Logs always have vertical asymptotes and exponentials always have horizontal.
Okay.
All right. So now we're interested in what I need to plug in. Notice I've got something in the middle with x, so that means I need to come over to the side. All right, so what are some values I need to think about over here on the side?
1/9,
1/9,
1/3,
1/3,
1,
1,
2,
3, and 9. Everybody know where we're getting those from?
Because they're exponents of
Yeah, they're multiple, I guess. Yeah.
Who said no? Okay. This one right here is always 1 over this thing squared. So 1 over 3 squared and then just 1 over 3. The middle one is always going to be 1. And then I've got 3 to the first and 3 squared.
Okay.
Every time. Whatever this is. Alright, since I've got something inside, I set that equal. And actually, I'm not going to worry about the 1/9, that's too small. So I have x plus 7, x plus 7, x plus 7, and x plus 7. So when I subtract 7 over, that gives me 2. When I subtract 7 over, that gives me -4. Subtract 7 over gives me -6. And subtract 7 over gives me -6 and 2/3. Then I always like to plug the bottom ones in. So let's plug 2 in. 2 plus 7 is 9. 3 to what power is 9? 2. 2 minus 2 is
0.
0. So that means this one is 0. I plug in -4. -4 plus 7. 3. 3 to what power is 3? 1 minus 2? -1. Once I have those two numbers, I should know what the next two are. What do the next two have to be?
-2 and -3.
-2 and -3. So graph my vertical asymptote, which gives me that. I've got -6 and 2/3 and -3, which gives me that. I've got -6 and -2. I've got -4, -1. Hold on, what did I do wrong?
Yeah.
No, that's right. -4, -1, and 2 and 0, which is right there. So from that, we should be able to see that it's going to curve this direction, and it's going to go that direction. So you're finding shifts, vertical asymptote, you come over to the side to figure out what your x values need to be, figure out a couple of your y's, you should be able to see the pattern to get your other y's. Then plot it all and graph it. Let's try another one. Do this one and one more. So y equals negative log base 2 of negative x plus 3 plus 1. So over x, what else? Over the y, what else? It's actually right 3, and then we have up 1. How do we figure out that it's right 3? Yeah, if there's a negative, remember if there's a negative inside, I got to pull it out. And that shows me that it's right 3. Right? What's my vertical asymptote? X equals positive 3. What tells me it's positive 3? Because the right 3 tells me it's positive 3. So I've got some stuff inside with x, so that means I want to come over here to the side. So what numbers do I need to consider over here on the side? 1/4, 1/2, 1, 2, 4, and since I'm dealing with 2, I might as well go ahead and go to 8. Alright, then I'm setting these equal to what's inside, which is negative x plus 3. So that means I need to subtract 3, which gives me 5, but then what do I have to do? I have to move the negative, so it turns into negative 5. I subtract 3, which gives me 1, but then it turns into negative 1. Subtract 3, which gives me negative 1, which turns into a positive 1. Subtract 3, which gives me negative 2, turns into positive 2. Subtract 3, which gives me negative 2.5, it turns into a positive 2.5. Subtract 3 is a negative 2 3/4, so it turns into a positive 2 3/4. Alright, then I like to do the bottom 2, so if I plug in negative 5, it turns into a positive 5. 5 plus 3 is 8. 2 to what power is 8? 3. Don't forget about this negative, so that means the 3 turns into a negative 3, and negative 3 plus 1 gives me.
Why did you do the negative? Oh.
Alright, so the negative 1, plug into the negative 1, that turns it into a positive 1. 1 plus 3 is 4. 2 to what power is 4? 2, it turns into a negative 2. Negative 2 plus 1 is negative 1. Once I have those two, I can figure out the rest of them. What does the next one need to be? 0. The next one needs to be 1, 2, and 3. Alright, so vertical asymptote at x equals 3. And then I've got negative 5, negative 2, bless you, negative 5, negative 2. I've got negative 1, negative 1. I've got 1, 0. I've got 2, 1. And then I've got 2.5, 2. And 2.5, 2 is probably enough information. So from that, I should see that it's going to go up there, and it's going to flatten out a little bit on the left. And I forgot to do it again on the last one, but what's my domain of this function? Negative infinity to 3, because my left is negative infinity, my right would be 3. All right, one more. So we have y equals an after log of x plus 3. Left 3. So that means my vertical asymptote is x equals negative 3, so it's always left 3. got something inside with the x, so that means I need to do a little bit of work on the right side, or out to the side. So what numbers do I need to think about over here? A little bit different. No. What's my base? E. So what numbers do I need? 1 over e squared. 1 over e. I need 1. I need e, and I need e squared. Okay? So x plus 3, x plus 3, x plus 3, x plus 3, and x plus 3. Now, on all of these except for this one in the middle, I'm going to have to use my calculator to help me figure out what e is. Alright, so I can go ahead and do the one in the middle, and that's going to give me what? -2. Alright, everything else I'm going to need help on. So this is 1 over e squared minus 3. So 1 divided by e squared and then minus 3. So that is -2.864. The next one is 1 over e minus 3. That is -2.632. Then I have e minus 3, which is -0.281. Then I have e squared minus 3, which is 4.389. Alright, so obviously I'm going to work on this -2 first, because that's going to be the easiest to plug in first. So if I plug -2 in here, -2 plus 3 is 1, and anytime the inside is 1, I get
It's
0. Anytime the inside of the log is 1, my answer is going to be 0. Okay? Now, on the other ones, I'm going to ignore these numbers, and what I really want to think about is, I'm going to ignore this as well, and I'm going just to think about, if this was natural log and this thing is e, what do I get? So what is the natural log of e? It would be 1. So that means this is 1. And once I have those two, then I've got my pattern for the rest of it. This one right here has to be 2, this one has to be -1, and this one has to be -2.
Okay, we're kind of good.
Okay. So I've got 4.389 and 2. So 4.389 and 2 somewhere in there. I've got -2.81 and 1. So -2.81 and 1 somewhere in there. -2 and 0. I've got -2.632 and -1. So that's going to be about right here. I forgot to put my vertical asymptote, which is -3. So I've got enough dots to figure it out already. So I know this is going down this way, and that's going that way. What's my domain on this function? -3 to infinity would be correct. Okay, so we take our shifts, we get the vertical asymptote, then it's always 1 over my base squared, 1 over my base, 1, my base, and then my base squared. If I've got something equal to it, then I set it equal and figure out what x values need to be in. I prefer to get the bottom two. Once I have 2 of them, you should be able to see the pattern and finish the pattern. Okay, it's not always going to be 1 apart. Sometimes they can be 2 apart or 3 apart. It just depends. So that's why you need to figure out what 2 of them are. Once I figure out what 2 of them are, then I can figure out the rest of the pattern. Graph my asymptote and my dots and graph it. That's all there is to it. Okay? All right.